The National Electrical Code, specifically Section 406.5c, addresses the face of a recessed panel board. According to the section, the face of a recessed panel board should not be set back more than 6 mm, which is equivalent to 1/4 inch, from the surface of the wall or panel board enclosure. It is important to note that while this requirement explicitly applies to recessed panel boards, the code often refers to panel boards and electrical boxes interchangeably. However, the NEC does not specifically address the use of quick-fix spacers or similar devices that are designed to support the receptacle yoke when a box is recessed. With respect to fire-rated wall requirements, the NEC does not specify a maximum setback for electrical boxes installed in fire-rated walls. Nevertheless, it is crucial to use fire-rated boxes and mounting systems in such installations to maintain the integrity of the wall's fire rating. If the electrical box setback exceeds 1/4 inch, there are several viable solutions. Firstly, you can cut out the existing box and install a plastering of the appropriate depth to bring the box flush with the wall surface. Secondly, consider using a box extender, which is designed to increase the depth of the existing box. Thirdly, you could opt for a deep box that is specifically designed to be recessed further into the wall. Although the NEC does not explicitly mandate it, adhering to the best practice of keeping the face of electrical boxes as flush with the wall surface as possible is always advisable. This practice helps prevent damage to the drywall and ensures the proper operation and secure mounting of devices and receptacles. The device that resembles a device box with varying depths is likely a drywall extension ring. These rings are used to extend the depth of a box when the drywall is thicker than the standard box depth. It is essential to remember that all electrical work should be performed by a qualified electrician while strictly adhering to local codes and regulations. When dealing with electrical box installations, several aspects warrant careful consideration to ensure safety and compliance with the National Electrical Code, or NEC. Firstly, the primary concern involves the depth at which the electrical box is set back from the finished wall surface. The NEC provides specific guidelines regarding the maximum allowable setback for panel boards, which, while not explicitly stated for electrical boxes, serves as a reasonable standard to follow. The 1/4 inch setback rule, derived from NEC section 406.5c for recessed panel boards, is a good benchmark to keep in mind. Secondly, the use of devices such as quick-fix spacers comes into play when addressing boxes that are recessed too far. While the NEC does not explicitly endorse or prohibit these spacers, their use should be evaluated in terms of whether they provide a secure and stable mounting for the electrical devices. They should not compromise the electrical connections or the integrity of the box itself. Thirdly, fire-rated walls present a unique challenge. In these walls, maintaining the fire-resistant properties is paramount. The NEC mandates the use of listed fire-rated boxes and associated hardware to ensure that the fire rating of the wall is not compromised by the electrical installation. The selection of appropriate fire-rated boxes is critical. Fourthly, when the setback exceeds the acceptable limit, alternative solutions must be considered. These can include using box extenders, which increase the depth of the box without requiring its removal, or employing plaster rings to bring the box flush with the finished surface. The choice depends on the specific situation and the extent of the setback. Fifthly, the selection of the correct type of box is also essential. Deeper boxes may be necessary in situations where multiple conductors or devices are being installed, or where the wall finish is particularly thick. The box must provide adequate space for the wiring and devices, while still maintaining a secure and flush mount. Sixthly, ensuring that all electrical connections within the box are properly made and that the conductors are adequately protected is paramount. Overcrowding the box or using improper wiring methods can lead to overheating and potential fire hazards. Seventhly, the mechanical integrity of the box and its mounting is critical. The box must be securely attached to the wall framing to prevent it from moving or becoming dislodged over time. This is particularly important in areas subject to vibration or physical stress. Eighthly, adherence to local electrical codes and regulations is mandatory. These codes may impose additional requirements or restrictions beyond those specified in the NEC. Always consult with local authorities to ensure compliance. Ninthly, it is essential to consider the long-term implications of the installation. The electrical system should be designed and installed to accommodate future needs and potential modifications. This may involve using larger boxes or conduit to allow for future expansion. Tenthly, a thorough inspection and testing of the electrical installation are crucial to ensure that it meets all safety and performance requirements. This should be performed by a qualified electrician to identify any potential problems or deficiencies. In addition to these considerations, it is important to maintain accurate documentation of the electrical installation, including wiring diagrams and specifications. This documentation can be invaluable for future maintenance or modifications. Also, consider the environmental conditions to which the electrical box will be exposed. In damp or wet locations, use weatherproof boxes and fittings to prevent corrosion and electrical hazards. Furthermore, ensure that the electrical box is properly grounded to provide a safe path for fault currents. The grounding system should be installed in accordance with NEC requirements. Remember to coordinate the electrical installation with other building systems such as plumbing and HVAC to avoid conflicts and ensure proper clearance. Also, provide adequate access to the electrical box for future maintenance and repairs. Avoid locating the box in areas that are difficult to reach or obstructed by other building components. Moreover, consider the aesthetic appearance of the electrical installation. Use flush-mounted boxes and cover plates to create a clean and professional look. Remember to protect the electrical box from physical damage during construction and renovation activities. Use temporary covers or barriers to prevent debris and impacts from damaging the box. Also, ensure that the electrical box is properly labeled to identify its purpose and the circuits it serves. This will facilitate future maintenance and troubleshooting. Furthermore, provide adequate ventilation for the electrical box to prevent overheating. Avoid installing the box in enclosed spaces where heat can build up. Remember to inspect the electrical box periodically for signs of damage or deterioration. Replace any damaged or worn components to maintain safety and reliability. Also, ensure that the electrical box is properly sealed to prevent the entry of dust, moisture, and insects. Use appropriate sealants and gaskets to create a tight seal. Furthermore, consider the potential for electromagnetic interference when locating the electrical box. Avoid installing the box near sources of electromagnetic radiation, such as transformers and motors. Remember to use surge protection devices to protect sensitive electronic equipment from voltage spikes. Install surge protectors at the service entrance and at individual branch circuits. Also, ensure that the electrical box is properly bonded to the building's grounding system to minimize the risk of electrical shock. Use bonding jumpers to connect the box to the grounding electrode conductor. Furthermore, consider the potential for vandalism when locating the electrical box. Install tamper-resistant covers and hardware to prevent unauthorized access. Remember to provide adequate lighting in the vicinity of the electrical box to facilitate maintenance and repairs. Install a dedicated light fixture or use a portable work light. Also, ensure that the electrical box is properly supported to prevent it from sagging or pulling away from the wall. Use appropriate mounting brackets and hardware to provide adequate support. Furthermore, consider the potential for seismic activity when locating the electrical box. Install seismic bracing to prevent the box from collapsing during an earthquake. Remember to use corrosion-resistant materials when installing the electrical box in corrosive environments. Use stainless steel or other corrosion-resistant alloys to prevent rust and deterioration. Also, ensure that the electrical box is properly insulated to prevent condensation and moisture buildup. Use insulation materials that are compatible with the box and wiring. Furthermore, consider the potential for noise transmission when locating the electrical box. Install soundproofing materials to reduce noise levels. Remember to use fire-resistant materials when installing the electrical box in fire-rated walls. Use boxes and fittings that are listed for use in fire-rated construction. Also, ensure that the electrical box is properly sealed to prevent the spread of smoke and fire. Use fire-stopping materials to seal penetrations in fire-rated walls. Furthermore, consider the potential for arc flash hazards when working on electrical equipment. Wear appropriate personal protective equipment, or PPE, to protect against arc flash injuries. Remember to de-energize electrical equipment before working on it whenever possible. Use lockout/tagout procedures to prevent accidental energization. Also, ensure that the electrical box is properly ventilated to prevent the buildup of flammable gases. Use explosion-proof boxes and fittings in hazardous locations. Furthermore, consider the potential for static electricity buildup when working with electronic equipment. Use grounding straps and mats to prevent static discharge. Remember to use proper lifting techniques when handling heavy electrical equipment. Avoid straining your back or other muscles. Also, ensure that the electrical box is properly labeled with warning signs and safety information. Use labels that are durable and easy to read. Furthermore, consider the potential for chemical exposure when working with electrical equipment. Wear appropriate PPE to protect against chemical hazards. Remember to use proper ventilation when working with chemicals. Avoid breathing fumes or vapors. Also, ensure that the electrical box is properly cleaned and maintained. Remove dust, dirt, and debris regularly. Furthermore, consider the potential for biological hazards when working with electrical equipment. Wear appropriate PPE to protect against biological hazards. Remember to use proper hygiene practices to prevent the spread of infection. Also, ensure that the electrical box is properly disposed of at the end of its useful life. Recycle or dispose of the box in accordance with local regulations. Furthermore, consider the potential for environmental impacts when using electrical equipment. Use energy-efficient equipment and practices to minimize environmental impacts. Remember to conserve energy and water whenever possible. Also, ensure that the electrical box is properly managed to prevent pollution. Use spill containment and prevention measures. In the context of electrical installations, specifically concerning the setback of electrical boxes, it's essential to delve into the applicable sections of the National Electrical Code (NEC) to ensure compliance and safety. The NEC serves as the cornerstone for electrical installations in the United States, providing comprehensive guidelines for safe and effective practices. While the initial inquiry focuses on the 1/4-inch setback limitation, it's crucial to recognize that this dimension is primarily associated with recessed panel boards as outlined in Section 406.5c. However, the Code's explicit guidance on electrical boxes setback is less definitive, prompting the need for reasoned interpretation and best practice application. Quick-fix spacers, designed to address recessed receptacles, present a pragmatic solution, but their permissibility hinges on whether they maintain secure and stable device mounting without compromising the electrical connections or box integrity. The NEC doesn't explicitly prohibit or endorse these devices, necessitating a judgment based on their functional impact on safety and compliance. In fire-rated wall assemblies, maintaining the fire resistance rating is paramount. The NEC mandates the use of listed fire-rated boxes and associated hardware to uphold the wall's integrity. These specialized boxes are engineered to prevent fire and smoke propagation, ensuring compartmentation during a fire event. Selecting appropriate fire-rated boxes is critical to meet code requirements and safeguard building occupants. When the setback exceeds the 1/4-inch threshold or otherwise compromises the installation, several corrective measures can be employed. Box extenders offer a means to increase the box depth without complete removal, while plaster rings provide a flush mounting surface. Alternatively, using deeper boxes designed for thicker wall finishes can provide a compliant and aesthetically pleasing solution. The choice depends on the specific scenario and the extent of the setback. Beyond addressing setbacks, proper box selection is vital for accommodating conductors, devices, and wiring methods. Boxes must provide adequate space for conductors without overcrowding, which can lead to overheating and insulation damage. Furthermore, the box must be suitable for the intended environment, whether it's dry, damp, or wet, and must be mechanically robust to withstand physical stress. Secure mounting is essential for maintaining electrical connections and preventing strain on conductors. Boxes must be firmly attached to the building structure using appropriate hardware to prevent movement or dislodgement over time. This is especially important in areas subject to vibration or seismic activity. Adherence to local electrical codes and regulations is non-negotiable. These codes may impose additional requirements or restrictions beyond the NEC, reflecting local conditions and priorities. Consulting with local authorities and licensed electrical inspectors is crucial to ensure compliance and avoid costly rework. The electrical installation should be designed and installed with consideration for future needs and potential modifications. Using larger boxes, conduit, and raceways can facilitate future expansion and alterations without disrupting existing wiring. This forward-thinking approach enhances the system's adaptability and longevity. Before energizing the electrical installation, a thorough inspection and testing are essential to verify compliance with codes and standards. This includes checking wiring connections, grounding, bonding, and overcurrent protection. A qualified electrical inspector should conduct the inspection to identify any deficiencies or potential hazards. Accurate documentation, including wiring diagrams, panel schedules, and equipment specifications, is invaluable for future maintenance, troubleshooting, and modifications. This documentation should be readily accessible to qualified personnel and updated as necessary to reflect any changes to the electrical system. Environmental conditions play a significant role in electrical box selection and installation. In damp or wet locations, weatherproof boxes, fittings, and wiring methods are necessary to prevent corrosion, water ingress, and electrical hazards. Proper sealing and drainage are essential for maintaining the integrity of the electrical system. Effective grounding is paramount for electrical safety. All metal boxes, enclosures, and equipment must be properly grounded to provide a low impedance path for fault currents, minimizing the risk of electrical shock. The grounding system must comply with NEC requirements and be regularly inspected and tested. Coordination with other building systems such as plumbing, HVAC, and fire protection is essential to avoid conflicts and ensure proper clearance. Electrical boxes should be located away from water pipes, ductwork, and other potential hazards. Accessibility is a key consideration when locating electrical boxes. Boxes should be readily accessible for maintenance, repairs, and future modifications. Avoid locating boxes behind finished walls, ceilings, or equipment that would obstruct access. Aesthetic considerations also play a role in electrical box installation. Flush-mounted boxes, cover plates, and wiring methods can enhance the appearance of the electrical system and minimize visual clutter. Coordination with architectural finishes is important to achieve a seamless and professional result. Protection against physical damage is essential, especially during construction and renovation activities. Electrical boxes should be protected from impacts, abrasion, and other forms of physical damage that could compromise their integrity. Temporary covers or barriers can provide added protection. Proper labeling of electrical boxes is crucial for identifying circuits, functions, and voltage levels. Clear and durable labels should be applied to each box, indicating its purpose and any relevant safety information. Adequate ventilation is necessary to prevent overheating and condensation within electrical boxes. Boxes should not be installed in enclosed spaces where heat can build up or where moisture can accumulate. Ventilation openings or louvers can help to dissipate heat and humidity. Periodic inspection and maintenance are essential for ensuring the long-term reliability and safety of electrical boxes. Boxes should be inspected for signs of damage, corrosion, or loose connections. Any deficiencies should be promptly corrected to prevent potential hazards. Sealing and weatherproofing are crucial for protecting electrical boxes from environmental elements. Boxes should be properly sealed to prevent the ingress of dust, dirt, moisture, and insects. Weatherproof boxes and fittings should be used in outdoor or damp locations. Electromagnetic interference, or EMI, can disrupt the performance of sensitive electronic equipment. Electrical boxes should be located away from sources of EMI, such as transformers, motors, and radio transmitters. Shielded boxes and wiring methods can help to minimize EMI. Surge protection is essential for protecting electronic equipment from voltage spikes and surges. Surge protective devices, or SPDs, should be installed at the service entrance and at individual branch circuits to mitigate the effects of transient overvoltages. Bonding and grounding are critical for minimizing the risk of electrical shock and preventing equipment damage. Electrical boxes should be properly bonded to the building's grounding system to provide a low impedance path for fault currents. Tamper resistance is important for preventing unauthorized access and vandalism. Tamper-resistant covers, screws, and hardware can help to deter tampering and protect electrical equipment. Lighting is essential for providing safe and adequate illumination for electrical work. Adequate lighting should be provided in the vicinity of electrical boxes to facilitate maintenance, repairs, and inspections. Support and bracing are necessary to prevent sagging or pulling away from the wall. Electrical boxes should be properly supported to prevent them from moving or becoming dislodged over time. Seismic bracing is essential for preventing damage to electrical equipment during earthquakes. Electrical boxes should be securely braced to prevent them from collapsing or shifting during seismic events. Corrosion resistance is important for preventing deterioration in corrosive environments. Electrical boxes should be constructed of corrosion-resistant materials such as stainless steel or fiberglass to withstand harsh conditions. Insulation is necessary to prevent condensation and moisture buildup. Electrical boxes should be insulated to prevent condensation from forming on their surfaces, which can lead to corrosion and electrical hazards. Soundproofing is important for reducing noise transmission through walls and ceilings. Electrical boxes can act as conduits for sound, so soundproofing materials should be used to minimize noise levels. Fire resistance is essential for preventing the spread of fire and smoke. Electrical boxes should be constructed of fire-resistant materials and properly sealed to prevent the passage of flames and smoke. Arc flash protection is necessary to prevent injuries from electrical explosions. Electrical workers should wear appropriate personal protective equipment, or PPE, when working on energized electrical equipment. Explosion proofing is important for preventing ignition in hazardous locations. Electrical boxes should be constructed of explosion-proof materials and properly sealed to contain any potential explosions. Static electricity control is essential for preventing damaged sensitive electronic equipment. Electrical workers should use grounding straps and mats to dissipate static electricity and prevent electrostatic discharge. Lifting techniques should be used when handling heavy electrical equipment. Workers should use proper lifting techniques to prevent back injuries and other musculoskeletal disorders. Warning signs and labels are necessary to alert workers and the public to potential hazards. Electrical boxes should be clearly labeled with warning signs and safety information. Chemical exposure prevention is essential for protecting workers from hazardous chemicals. Electrical workers should wear appropriate PPE when working with chemicals and use proper ventilation techniques. Biological hazard control is important for preventing the spread of infectious diseases. Electrical workers should follow proper hygiene practices and wear appropriate PPE when handling potentially contaminated equipment. Waste disposal should be done so as to handle old items appropriately, recycle, and minimize harm to the environment. Electrical boxes should be disposed of or recycled in accordance with local regulations. Environmental impact minimization practices are necessary for preserving natural resources. Electrical workers should use energy-efficient equipment and practices to minimize environmental impacts.